In this video, we're going to start talking about the chi-squared tests, which is another one of our hypothesis testings. First thing, there are two different types of chi-squared tests. One is to show independence, and the other one is called goodness of fit, and that one is to determine if your data fits a given distribution. In this video, I'm going to focus on the chi-squared test for independence. Before we get started, we're going to be talking about general steps for both chi-squared tests, and then we're going to focus on the independence. So first, chi-squared. Where does this name come from? Well, it comes from the chi-squared distribution. So as you see the distribution graph here, it's not exactly like a normal distribution because it's not symmetrical. But it works in the same way where the area under this curve is always equal to 1. So it's a probability distribution graph. You don't need to know this for the DP course, but it's useful to understand because we're going to be comparing still the p-value, and then we'll also be comparing this critical value that we're going to discuss about. One thing that we need to know is that the parameter for this curve, or the reason why this curve changes, is the degree of freedom. And we're going to go more in focus of the degree of freedom in our next video. This number here, the chi-square critical value, is sometimes given to us in the questions, and we compare that with our chi-square calculated value, which is the calculator that's going to give it to us. Good, so chi-square is going to be given, or the significance level, and then we know, like the t-test, that the significance level is compared to the p-value from the calculator. This is what I mean by the degree of freedom. So depending on what the degree of freedom is, it actually affects a little bit the layout of our curve. So making it either a little bit flatter, the more we have the degrees of freedom. But again, you don't need to know this. I'm always going to be using a typical chi-squared curve to understand the conclusions, but you don't need to know what it actually looks like. Okay, the most important slide for us, these are the conclusions. So to reach our conclusion, we're going to be using either one of these. So it's going to be either we are going to be rejecting the null hypothesis. Now, we know we reject the null hypothesis when our p-value is smaller than our significance level, right? So that's where we reject our null. But you're also going to see that we're going to talk about this chi-square calculated value. Now, this chi-square calculated value, if it's bigger than the critical value, which is given in the question, well, we're going to be in the zone for rejecting the null. And in the other case, if our chi-squared calculated value, what's given to us in the calculator, is smaller than this critical value, so we're in this region here, well, we're going to be not rejecting the null, so that means we're going to be accepting our null hypothesis. And that's the same thing as if our p-value is bigger than 0.05, we accept our null hypothesis. So we're going to be playing around with both of these conclusions for today. Let's go more into detail about the chi-squared test itself. The steps for any chi-squared test is first our null and alternative hypothesis. Now, the point of this test is that we are proving that either two variables are independent or not independent to each other. So your null hypothesis will always be that whatever the two things you're comparing will be independent. And the other one is that they are not independent, or you can use the word dependent here. So always going to be the exact same null and alternative hypothesis. Our degrees of freedom, we are going to talk about this a little bit more, but what you need to know is that with your calculator, you're going to do row one, so the number of rows you have, -1, and then you're going to multiply that by the number of columns you have, -1. I'm going to come back to this. And then in the calculator, you're going to be putting all the information for our matrices, actually. So as we go, you're going to see we have to create matrices to put the information in, and then we run a chi-squared test. So this step that we put in the GDC is going to give us a p-value, or it's going to give us a chi-squared calculated value. And based on what is given in the question, we will be comparing these values to what's given in the question. Okay, let's get going with this and understand how to use our calculator. This is in our first question. We have Sanvi wants to know whether or not the choice of game is independent of gender. A chi-square test for independence shows whether two data sets are independent of each other or not. It can be performed at various levels of significance. In this case, Sanvi decides to perform a chi-square test for independence at a 5% level of significance to find out whether the preferred game is independent or not. I also gave you extra information, and I'm saying given the 5%, given the critical value for 5% significance is 5.991. So this 5.991, it represents our chi-squared critical value. Okay, first thing what we have to do is we have to create a table that's going to help us understand the data that is here. In our table, we need to create it so that there's only numbers in here. Right now we have quantitative data, qualitative, sorry, and we want to have quantitative. So we don't have numbers. So we notice that there's two genders. So that's going to be one of our category, gender. And then there's three different sports, badminton, squash, and tennis. So the first thing that we're going to be doing is creating this table. So we have our gender and then we have our sports on the top. What you do is you look at your table and you say, okay, how many males are playing tennis? And you count, okay, 1, 2, 3, and then when you count all of these male tennis players, you get the value of 10. So how did I get all these numbers here? I simply looked at my table and then I matched it here. Then we add up our totals. So we have 33 males and we have 27 females. We have 20 badminton players and so on and so forth. There's a total of 60 people who took this survey. Now, the first step is that we need to, this is our observed data. This is what's given to us for our test. And now we need to do the expected data. So we need to calculate the expected data. First thing, when we calculate the expected data, all the totals will remain the exact same. So all the totals that I have from my observed data will stay. Next, how do you calculate the expected value for male tennis players? Well, what you have to do is you have to go look at the column for tennis. You have a total of 19 for tennis, and then total for male is 33. In order to calculate this expected value of male tennis, we're going to look at the probability of tennis. Now, the probability of tennis is our 19 over 60, while the probability of male is our 33 out of 60. So what you have on the right-hand side of the screen is the calculation. 19 over 60 times 33 over 60, that's the probability of having tennis and male. And then we multiply that by 60 because we want to have the expected value, not just the probability of it, but the expected value. So we get a fraction answer, and I just converted that to a decimal, and I got my 10.45. So you have to do this calculation for every single value that you have here. So for example, I did the second calculation here, which was for, let me change colors, which was for badminton and male. So badminton and male, we go 20 over 60 times 33 over 60, and you multiply that by 60, and you get the value of 11. So these are tedious calculations, but we can do those with our calculator. And when you do all of those calculations with your calculator, then you're ready to put them into your table. Notice that if you add up all these numbers, it should still add up to 33 if we did the calculations correctly. We do the same thing for female, and then we put these in. Again, they should all add up to 27, and then your columns should add up to whatever the total was down here. So first step is the expected value, right? We need to calculate this expected value. Once we have this, this is where we're going to be putting all of this information into our calculator. We need to input this information as a matrix. How do we do that? In your calculator, you're going to click on second, and the matrix button is just over the x negative 1. So you click on matrix. You go towards the right, and you edit your matrix. So let's say I take A. I edited A. 2 by 3 matrix. Why? Because we're not using our totals. So the totals are not part of the matrix, but all the other numbers are part of the matrix. So it's a 2 by 3 matrix, and then you see the matrix pops up, and then you can input your matrix A, can be your observed matrix, and then we can do the same thing for your expected matrix. So we'll go and edit a second matrix, 2 by 3, and then we input everything for the expected matrix, but again, no totals here. So we have the observed is in our matrix A, and we have that the expected is in our matrix B. Let's go ahead and do some calculations. Now we're going to go into stats, test, and we need to scroll down until we find our chi-squared test. Notice that there's two chi-squared. The first one is going to be our independence. The second one is the goodness of fit. So I choose this first one. Now remember, my observed and expected were A and B. So I need to go change the names of these. In order to change the names of these, you're going to go second matrix, and you're going to choose which one you want. I wanted A for observed, and expected, I want B. So second matrix, I'm going to choose B. Now that I have A and B, I go ahead and calculate. When I calculate, I see the chi-square calculated value and the p-value. And we're going to go ahead and reach our conclusions by comparing these to what's given in the question. Okay, what's given in the question is that our chi-square critical value is 5.991, right? So this is the number that was given in the question. Our chi-square calculated value is 7.09 if you round to three significant figures. Notice that this number is bigger than our critical value. So we're in a situation where we are going to be rejecting the null hypothesis. Now we could have also used the p-value to calculate this. Remember, we're doing a 5% level of significance, so the p-value we calculated was 0.0289, and this is in fact smaller than 0.05. So both of these together are reaching the conclusion that we're rejecting the null hypothesis. Once we reject the null, that means that we are accepting the alternative. So we're accepting that the preferred racket game is not independent of gender, or in another way, they're dependent to each other.
Okay, now that we've done the long way of solving these questions, let's look at the actual way we're always going to be solving these questions. The calculator can find all your expected values for you. So I'm going to show you this shortcut in your calculator. However, everything you've just done is not a waste of time because the expected values are asked to calculate from the IB, and you need to show you're working out for all of these questions. So really good practice that we just did. Okay, example 2. 80 people were asked for their favorite genre of music, pop, classical, folk, or jazz. The results are shown in this table. A chi-squared test carried out at a 1% level significance. The critical value for this test is 11.345. Write down the null and alternative hypothesis. Show that the expected value for female liking pop is 21. This is an example of how the IB asks you to show expected values. Find the chi-squared test statistics of the chi-squared calculated value and our p-value, and then state whether the null hypothesis is accepted or not and give your reason for that. Okay, let's start with our null hypothesis. So if we're trying to do this test here, we're trying to show that types of music is independent or not to males. So we're going to run a chi-squared independence test. The null hypothesis has to be that favorite music genre is independent of gender, while the alternative is going to be that they are not independent, so they're dependent. For part B, they're asking us to find the expected value for female. Now, here's going to be the shortcut. In your calculators, you can simply input the matrix for the observed data. So I'm going to ask you to take some time right now, pause the video, and insert the matrix for observed data while I show the observed data. Make sure that when you're inputting your matrix, you're not inputting the total columns or rows, so really only the raw data that we have. Once you have your matrix inserted, then we can go and run a chi-squared test. So we're going to go into test. We're going to find our chi-squared, not goodness of fit, but just chi-squared. And our observed, I called my observed matrix A. This matrix can be absolutely any letter you want. It doesn't matter what it is, as long as it's not A. And then we're going to go ahead and calculate. Remember, my expected was in the B. So let's go ahead and calculate. Okay, we'll come back to this value for question D and question E. But first, I'm going to show you a little trick. Remember how I told you that your expected values are in matrix B? Well, you're going to go back into matrices, And you're going to go into this matrix B, and you're going to see that now all these values are inserted for you. That means that they did the expected matrix for you. Question B asks, show that the expected value for female liking pop is 21. Well, female liking pop, so we have female pop. This is the observed value. Therefore, the expected value for this one should be 21. But it's a show this question. So we know for show that questions, we need to actually show our working out. So let's do that. For female, we're going to have 42 were female out of a total of 80, 40 liked pop out of a total of 80, and then we multiply that by 80 in order to have our expected value. And in fact, we do get 21. So use the calculator to make sure your answer is correct, but always show you're working out for this question. Okay, coming back to the page where we had our stats test information. So if we run this information here, this was the important information. So we need to know what is our chi-squared value and what is our p-value. Now we're going to compare this to what was given to us in the question. In the question, we were given our chi-square critical value, which was 11.34. So I did a little diagram here because I like to have this diagram where the chi-square critical is given, and I compare this to the chi-square calculated value. I put these two on the number line, and I notice that the chi-square calculated value is definitely smaller than my critical value. So this would be in the region of accepting the null hypothesis. But what I will also want to do is I want to test the p-value versus the significance level. The significance level in this question was 0.01, and I will compare that to my p-value. In fact, my p-value is way bigger than the p-value of 0.654 is way bigger than the significance level. Therefore, this is also an accept the null hypothesis situation. So since we are accepting the null hypothesis, we are accepting that the favorite music genre is independent of gender. Let's look at a final question for today. Do students who take a certain Group 4 course tend to have a preference for their Group 3 courses? Do this at a 5% level of significance and test whether the students from Group 4 choice depends on the student from Group 3. So we're in a situation here that we are looking for dependency or independency. So we need to do a chi-squared independence test. And we are comparing group 4 choices and group 3 choices. So our null hypothesis is going to be that the choice of group 4 and group 3 are independent, while the alternative is going to be that the choice of group 4 and 3 are not independent. Okay, so now that we've done this, it's time to go into our calculators and find our chi-squared and p-value. Okay, so we're going to go and insert a matrix. It's okay if you always use A, that is not a problem. So here we have a matrix which is 3 by 3. So I'm going to change my numbers here, 3 by 3. And I'm going to put in the observed value. So pause the video at this point and put in your observed values. Once your observed values are in, we're going to go and run our stats test. And we're going to find our chi-squared test. There it is. And our observed was in A. And as long as this is not A, we are okay. So we can go ahead and calculate. Okay, so now that we have our chi-squared value and our p-value, we can compare this. In this question, we're not given the chi-square critical value. Therefore, we can't use this chi-squared value to compare, but we are given the significance level. So with the 5% significance level, I'm going to be comparing with my p-value. Good. So this p-value here, notice it's 4.176 e to the negative 4. So this means times 10 to the negative 4. If you write down that your p-value is only 4.17, that is incorrect. You need to have the times 10 to the negative 4, or you can write it as a decimal as you wish. So this should be written down on your piece of paper. Now we're going to compare this. Our significance level was 0.5, so that's the blue highlighted here. And then our p-value is definitely smaller than our significance level, so we are in the situation where we're going to be rejecting the null hypothesis. If we reject the null hypothesis, well, that means that the choice of group 4 and group 3 are not independent, so they definitely are dependent of each other.